In this video we'll be talking about projections. The basic idea is we want, given a vector f and a vector d, we want to find two more vectors, w and n, so that the picture looks like this. Here's the vector d. The new vectors will be here and here. We'll call this vector w. It goes from the start to here. And this vector n. And these vectors n and w have a couple of properties. W is parallel to d. N is perpendicular to d. And you can see if we take w plus n, we should get f. So f equals w plus n. The basic idea is we're trying to break f up into the part that is parallel to d and the part that's perpendicular to d. So, since w is parallel to d and n is perpendicular to d, there is a right angle right here. Actually, w is also perpendicular to d. So w is also perpendicular to d. So how do we find w? Well, since w is parallel to d, we can write w as a multiple of d. So all we need to really find is what this constant multiple of d is, what this c is. Let's see, and f is w plus n, w is c times d, so f is c d, a multiple of d, plus n. And now somehow we want to find c from here, so we're going to try dotting both sides of this equation with d. So let's do it. F dotted with d is equal to cd plus n dotted with d. And the distributive property for the dot product says we can distribute the dot product inside, so we get c d dotted with d plus n dotted with d. And now there's something really interesting about n dotted with d. Remember we said that n is perpendicular to d, so that means their dot product is equal to 0. So that means we have f dotted with d is equal to c times d dotted with d. And remember, we're trying to find the c value right here, so let's just solve for c. This is a number, d dotted with d, so we can just divide both sides by d dotted with d, and we get that f dotted with d divided by d dotted with d is equal to that constant c. So, remember, w is equal to c times d, so w is now equal to f dotted with d divided by d dotted with d, and that's a number divided by a number, so this whole thing is a number, times d. So this number right here tells us how much we need to multiply d by to get w. In this drawing we can see that this number should be about 2, because we multiply d by about 2 to get to w. And once we know w, how can we find n? Well, remember f is equal to w plus n, so n is equal to f minus w, or minus this thing right here. We give a special name to w here. W is the amount of the vector part of f that is parallel to d. We call w the projection of f onto d. W is the projection of f onto d. And the notation we give for that, because we use projections quite a bit, is PROJ for projection, of F onto D. We can think about W as, in some sense, the shadow of F onto D. If we have light that's shining from directly above, shining directly down on D, we can see that if we had a vector F here, the shadow of F would just be directly below it. It would be actually equal to W. The projection of F onto D is, in some sense, the shadow of F onto the line formed by the vector D. And so sometimes it's easy to confuse which one of these goes up here and which one goes as a subscript to the PROJ. If we're projecting F onto D, I remember that F is casting a shadow on D, so F is on top and D is the subscript here. Alright, so let's do an example. Let's say F is the vector 6, 2, and D is the vector 2, negative 1. So we have some situation that looks approximately like this. 1, 2, 3, 4, 5, 6. 6, 2, there's F, and D is 2, negative 1. There's D. And what we want to do is find the vector W, right to about here, and N, so that there's a right angle right there. This vector right here is called the projection of F onto D, and then this vector is what we've called N in our problem. So this projection, the projection of F onto D, is, as we've shown before, F dot D divided by D dot D times D, and F dot D is equal to 12 minus 2, which is 10, and D dot D is 2 times 2, 4, plus 1 times 1, which is 5. So 4 plus 1 is 5, and then times D, which is 2, negative 1. Or this simplifies really nicely. Here's 2, so we get 4, negative 2. That's the vector W. There's the vector W. And what's this vector N? N equals F minus W. It's the vector from the end of W to the end of F. And F is 6, 2. W is 4, negative 2. So we just get 2 minus negative 2 is 4. And we can double check to make sure that N and W are perpendicular to each other. 2, 4 dotted with 4, negative 2 is equal to 0. So those two vectors are orthogonal. Projections are used in many areas, including least squares, which is important in actuarial science, and many other areas in scientific computation. It's also used in work. So as an example, to calculate work is usually force times distance, the displacement distance, but that assumes that the force is in the direction of distance. But what if your force is being applied in a different direction than your object is moving? Well, in this case, what we need to do is figure out how much of the force is parallel to the direction of motion. And so the force that we use is actually the force projected onto the displacement vector here. And you'll examine that a little bit more in the problems. This concludes the video on projections.